What's up my people, and welcome to another video in Walrus Code. Whenever you publish an application to the public cloud, it becomes immediately available to thousands of users around the world. And we must somehow ensure that our servers are going to have the enough capacity to handle all those incoming requests from those users. One old and classic approach to solve this problem is just buy a huge server with many cores and a lot of RAM. The problem with this approach is that you buy a machine that has X capacity, I don't know, but the capacity may be not used all the time, and that means that translates into money loss. You are losing money just because your servers are having free available capacity that is not being used. But today's video is not about upgrading hardware, guys. It's about scaling out, horizontal scaling, which is like another point of view to increasing a server capacity. Instead of having one, you can in minutes or in seconds have 3 machines becoming all those incoming requests. That is one of the most powerful features of the cloud. You can provision and unprovision hardware in seconds. You can just pay for what you use. That is amazing, and that is really the power in autoscaling, I think. Today you have solutions like Kubernetes or the Elastic Container Service from AWS that enable you to orchestrate containers and scale them out and in, but I'm gonna show you today in the video of today a much simpler solution using autoscaling groups and load balancers in AWS. Okay my people, so let's dive in everything I explained in the introduction, but before I want to remember you, if you like this content, smash the like button. If you are new in this channel, subscribe to it. I am gonna upload a video like this every week from now on. So let's go for it. This is the diagram of the system I'm going to show you today. It is a very simple autoscaling group, but I'm going to explain every one of these components so you can have a clear concept, so you can finally, after the video, have a clearer mind about how do autoscaling groups work with containers, for example, and with EC2 instances. How can we set up them in order to trigger scaling events automatically, for example, with these parameters which we are seeing here? How can we track CPU or RAM or request count or whatever in order to trigger an scaling event? So we are seeing different AWS components here. Let's start with the EC2 instances. The EC2 instances are the servers that are gonna handle the incoming requests from the users. We are representing the users with this cell phone at the left of the diagram, and the more users you have, the more instances you are gonna need in order to handle all that load. So you are gonna need more or less instances, but those instances are grouped in what is called a target group, and that is also another component of the EC2 configuration. We are gonna see that everything in the console, as you can see here in the tabs. I have one tab for each of one of these components, but where are we gonna store the images? As you may noticed, these EC2 instances are running Docker containers. We have a containerized application, which is a Spring Boot application running in each container. So each instance has just one container. It is possible to run more containers in one instance when the instance has enough capacity or enough resources to load more containers. But in this special example, we are just going to have one container per instance. And also the instances, okay, they are running containers, but where do they get the image of this Docker container? We are storing Docker images in the Elastic Container Registry, as you may see here. That is also another service in AWS, which is an alternative to Docker Hub. Docker Hub, as you may know, that is another image repository or image registry to store images. You can use whatever you want, but yes. So how are we forwarding the request from the users to the instances? How can we do that if we have multiple instances, let's say 3 or 5? How can we, I don't know, calibrate, or how do you say, balance the load? That's why you have a load balancer, which its task, the load balancer is responsible for receiving all those requests from your users and balance them properly among every instance you have in this target group. So every instance is going to share the work, so to say, and you don't have any hot instance. I mean, a hot instance would be an instance that is overloaded with requests. That is what we do not want in this example. And all this is orchestrated by an auto-scaling group. This is the guy that triggers scaling events. This is the guy that notices, hey, we have one instance, we are exceeded in one instance. I mean, he can notice if we must dismiss one instance because we are having a very low demand, or it can also trigger increasing, how do you say, it can request more instances and so on. So yeah, basically that is the diagram about, and now let's head to the console, and we are gonna start, we are gonna start by seeing the only running instance that we are having at the moment. We are gonna trigger an event, so stay there. You will see, I mean, a running scaling out event in real time, I mean. So just stay there. This is an application running in Spring Boot. Actually, we can go to the load balancer. Okay. First of all, I want to clarify, we are mainly going to remain in the EC2 menu, dashboard, whatever you want to call it, but this is everything under the EC2 dashboard. You have here the instances, you have here at the left a menu where you see launch templates. That is also another topic we are going to see today. We see the AMIs, which are the operating systems that we can install in our instances, the security groups, the load balancers. I think the webcam, yeah, the webcam is just a little bit, okay, I think I cannot show that right now, but here is also the load balancer, the target group, and the auto scaling group. I recommend you to open also your AWS console, and you can see that with me at the same time, so you can learn also. So it is already running. Let's head to the load balancer. I would say every load balancer has a DNS where all other requests are gonna be sent to this DNS. You want to expose this DNS as a URL, for example, to this REST API. You don't want to send your clients, you don't want to send them the IP of each one of these EC2 instances. They are hidden from your clients. It is the task, it is the responsibility of the load balancer to forward, so to say, those requests to your machines. So we can copy this DNS and we can paste it in the URL and the browser, I mean, and it should fast forward. Exactly, that is what I expected actually. Our Spring Boot application doesn't have a default page in the root, but we can write this URL, for example, customer, and it returns back an array, just a JSON of data. It's dummy data, nothing important. But I also configured this URL, which returns back the internal IP, so to say, of the machine where the container is running. I'm gonna explain how did I do this, but later. So everything is running fine. We have a load balancer. We have just one EC2 instance. We have one target group. Now I am showing you the target groups, which are in the menu here at the bottom, which I cannot show because of the webcam, but yes, the target groups. This is where everything starts. So if we were to build this same instance, and now pay very much attention, I mean, if we were to build this whole system again, we have to start by creating this target group, and we can simulate it a little bit with a short example. We can choose target type instances, so on, group name, blah, blah, blah. That is not important right now. Yeah, protocol, you can use HTTPS if you want to secure to encode the data on flight, but this is not necessary for this simple example. And the health check path, that is also another important aspect. If you have this dependency installed in your Spring Boot application actuators, you can have this health check endpoint. I mean, this should return on a status app. This is the URL you want to use in your target groups if you are using Spring Boot for health check. I think you can also rewrite this URL and just expose it as health in order to have a shorter one, but yeah, that is just a detail. And then you click next. And if you have indeed at the moment of creation some instances that are already running in your and you want to register them on the target group you can select them. But it is not mandatory to start or create a target group with existing instances. You can also create a target group empty, and that is fine. That is actually what I did in the back then. So then you create the target group and that's it. I'm gonna leave this, cancel this process. And the second step, guys, in order to recreate this system is creating this guy here, the load balancer. And that is also in the menu from the EC2 dashboard. You have to go to load balancers here in the left, down here. And then you can choose among many load balancers which AWS offers you. You can create load balancer here, and I'm gonna explain shortly what is every one of these about, each one of these about what is. Okay, so you have the application load balancer, which is a classic load, no, it's not the classic load balancer. I mean, you have the classic load balancer, which is a deprecated load balancer. It was the first load balancer offered by AWS, but it is not recommended anymore to use it because you have more modern solutions, so to say. The application load balancers works at the layer 7 of the OSI model. That sounds a little bit abstract, but that means it redirects it's like a forwarding request at the HTTP or HTTPS level. On the contrary, the network load balancer works on a higher level, or no, on a lower level, I would say, the layer 4. It fast forward TCP, UDP, or TLS. And there's the gateway load balancer, which is more complicated to explain. I'm not going to explain that in this example, but you can research it for your own. And today I'm just using the application load balancer. I've seen the most popular ones are those ones. This is used if you want high performant, low latency applications. I mean, like real-time use case and so on, or thousands of requests per second and so on. But on general, I think this would be enough for normal applications which don't require so crazy performance requirements. Okay, and then you press create, you write their name. Internet facing, that means your load balancer is gonna be exposed to the public, and that is what you want if you are creating a public application hosted in the cloud for everyone to be for being reachable by everyone. But you also can create a load balancer that are private for your subnet. I don't know. So IPv4, yes, and you can choose the virtual private cloud wherever you want to host it. And I think you need at least to check 2 of those subnets. You must check at least 2 of them. I think it is a requirement, otherwise it won't create the load balancer. And you can choose a security group. That is also very important, because you can use then this security group to be the one and only one allowed to enter those instances. I mean, each one of these instances must have a security group, right? You have to set up rules, which ports are available to reward and so on. But if we have a load balancer exposed to the world, then we don't have to expose each one of these instances. And actually, it is a good security practice not to expose them, because you don't need to. So you can maintain them high to the HTTP protocol, for example, but you can make them accessible through SSH. I mean, if you want to connect to a particular instance and see what's going on, or upload a file, I don't know, you can configure that in the security group. But you can configure the security group actually in an elegant way and say, okay, this may be only accessed in the AT port of the HTTP protocol by this load balancer and by no one else. And then you have a very secure instance. And that's why this security group is very important for the load balancer. Okay, that was a little bit longer than I expected, but then you can choose a target group, and here comes the first connection between two of these elements of the system. You can connect a load balancer to a target group, which is very logical, and you do that here. I cannot select that one because that is already taken by my existing load balancer, but you can create a target group and assign them to the load balancer. And it's as easy as that. Let's cancel that, and whenever you are ready with that connection, actually you already may have a running application on the cloud that is also receiving incoming requests and redirecting or forwarding them to the instances. But that is not ready because that wouldn't be autoscalable yet. You would have to manually create instances and pull the Docker and install the container and so on. So you can build on top of that, on top of those both elements, an autoscaling group, and that is very easy to do. Also in this menu, you have this menu of autoscaling group where you can create an autoscaling group. I already created one, the one I'm gonna show you right now. And for autoscaling group, you can set the desired capacity, that is how many instances do you want to be running normally. The desired, I set it as 1 for the moment, and the minimum, you can also set a minimum of instances, and it is not going to go below that amount, believe me. And you can also set a maximum capacity in order to, that is like a secure thing, a secure best practice. So what happens if you receive thousands of users and you don't want to spend all the money in your account, in your credit card, creating an infinite number of instances? You can set a maximum in order to protect your savings, your billing account. And also that is very, very important, and that is one of the topics of the day of today, a launch template. What is this? Well, if we want to automatize the launching of instances, and we want to, so normally when you create an EC2 instance, you have to set up to choose operating system, the security group, the storage, what else, tags, metadata, the user data, which is in Amazon, the user data of an EC2 instance is just a script that runs at boot time. That is something very important that we are gonna see in this example, because that is the boot script we use to launch this container at install time. So how can we automate all of that, all of these steps? All of those steps of setting up a machine with an operating system and so on, it's all what is called a launch template. And let's head us to launch templates. We are now in the menu of launch templates. You can see it here. And you can create one. It's very easy. It's like actually almost identical to creating an EC2 instance. You set every of those steps. You have to choose the operating image, the operating system, I mean. You can choose your own AMIs. Actually, I chose my own one, which is Amazon Linux 2 with Docker. That is a very important point also of today. If we are using Docker containers, we want an operating system that has already Docker installed in order to save time, because you could actually use the raw AMI Linux 2, but it would take time to install Docker every time you launch a new instance, right? So why not create a new AMI Linux 2 with Docker? And that is very easy. If you didn't know, you can create your own AMI's images. It's just like you go to instances, and then you can, if you know your instance is an AMI2 Linux with Docker installed, you can select it, then right click on it, and then there is this option to, yes, image and templates, create image. As easy as that. And then you can store an image. This is like a copy of everything that is installed in that instance, and then you have your own ME Linux with Docker. Very, very, very practical. So I did that in this case. And then you can choose the instance type in order to, this is just an example. So I choose the T2 micro, I mean, which is free tier eligible. If you want to save money, you can use this. But actually, that is enough. That is like a very, very small machine that is enough to run a little container, Docker container. Hey, who knows? Maybe that is enough for your project. I don't know. But you can choose an instance type. I don't know if you can choose multiple instance types. I don't think so. But if you need multiple instance type, then maybe you can create multiple autoscaling groups. I don't know. Yeah. So keep here login. Yes. So it's everything the same as installing, launching manually an EC2 instance. But we want to pay attention to this thing. There is this thing called the user data. And the name is very confusing for me because user data for me was like, okay, should I put something about me? Like, no. This is the script that runs at boot time, and it is a script that can be batch or shell script, where you can install or run containers. Let's head to my launch template, the one I created, and I'm gonna show you right now what did I use as a boot script for this example. So we do have this Spring container, and you can version your launch templates. This is very practical because every time you make a modification, it is going to save a new version. So I'm gonna select the last one. And in advanced details, I can show you the user data. That is the script I run every time at boot time whenever the autoscaling group creates a new instance. And that is, let's pay attention to it, because what does it do? It's very simple. First, I think it must have this at the top in order to explain that it is a batch, but I don't know, maybe you can omit, I don't know. I would let it there. So then, as the Docker service is already installed, we just have to launch it, and then we can pull the image from the Docker registry, Elastic Container Registry, as we are showing here. This is the name of the image, yes, that is the name. And then I create a folder because I use volumes, actually not volumes, but a bind mount. I use a bind mount in Docker in order to store the logs and being able to access to the container logs from the outside and sending them to CloudWatch. I'm not sending them to CloudWatch in this example, but that would be very easy to do. I just would have to add an extra step to install the CloudWatch agent and configure it to get the logs. But yeah, I create, so we can do anything in this script, creating folders, setting permissions. And then this last command is the docker run, which launches the container based on this image that we already pulled. I set the ports, the name, the bind mount is here, and I pass here a very important variable that is an environment variable with the host name of this same machine. So that is how our application is aware of the service it is running. I don't know if this is actually a good practice. Maybe the container should be like totally unaware of where it is running, but for this example purpose, I wanted to do this because I'm gonna show you right now that the load balancer is working whenever we see the machine is changing. But yeah, you're gonna understand that now. So that runs the Docker container, and that boots up the application, and then the application is running the new instances. So just as simple as that. And then yes, this is my Amazon machine that I want, a machine image that I wanted to show you with Docker, but it's nothing special about it, just an AMI Linux 2 with Docker. So let's head again to the autoscaling group. we are already running this application as I saw you. If I go to this route, server ID, I know that this application is just running on this machine, because if I refresh the page, I know the number here remains the same. So I know there's only one instance receiving all the requests. But now, okay, let's talk about how is autoscaling triggered. How can we configure this? And then I'm gonna set a manual autoscaling event. I'm gonna scale it up to 2 instances. But first, don't forget to smash the like button and subscribe if you're new in this channel. I'm gonna upload this content every week. If you like it, subscribe and like, and share the link to everyone that you may know might be interested in learning technologies, programming, front-end, back-end, or mainly back-end, I would say. Back-end, cloud, AWS, and so on. So we have the autoscaling group. First, I'm gonna trigger a manual event. Here I can increase the capacity. I'm gonna increase the minimum capacity. No, that may remain in 1, but the desired to 2. The maximum can remain also. So now I am increasing 1 the desired capacity, and that is automatically gonna launch a new instance. Now I do have only 1 instance running, but in a couple, you see, now it appeared one pending instance just a couple of seconds after I increased the desired capacity. And now if we head to activities, every scaling group has an activity log, which is very useful to track down what has been happening in the last minutes. And here we see pre-in service, so it has been launched. It is gonna launch a new EC2 instance, and this event was launched like now, a couple of seconds ago. So while the instance is being provisioned by AWS and the container is being boot up, I'm going to explain to you this. Dynamic scaling policies. These are the policies that track the metrics that are going to trigger automatically scaling events, like scaling out or scaling in. Don't forget that scaling in means the dismissal of instances that are not needed anymore. This is the tracking policy I created for this group. We are particularly tracking the CPU usage, and whenever it reaches 70% or above of usage, it is going to create a new instance. Just as easy as that, and it has a cooldown of 300 seconds. No, not a cooldown, a warm-up before it. Oh yeah, so that means whenever the instance is launched, it is not going to send metrics in the first 5 minutes. But there are other ways to track metrics. I can show you right now. So I can edit this policy. So I can choose another metric type, not average use of CPU, but network in or network out. Those are the amount of network data that is going in and out, I think. Yep. I've never used those metrics before, but I imagine it has to do with the payload. How big is the payload coming in or the response going out? So it's a measure. It is like a measure of communication between users and instances, which also increases when the user increases, right? And the request count per target, another measure that increases when the users increase in our traffic or in the demand. And the target value, you can choose here another, for example, 50%. And the instance needs seconds to warm up, blah, blah, blah. Yeah, you can change those 300, but those are the default. And you can actually disable scale in. That means you can automatically scale out, but you have to manually dismiss the instances. There may be a use case for that. I have not used it until now, but there are other ways to set scaling policies. Actually, let's create a new one. For example, if you don't want tracking, you can set up step scaling, which is much simpler. I mean, although I prefer tracking personally, but you can step scaling by just watching a CloudWatch alarm, The only one that I have available now is the billing alarm, which tells me if I have exceeded in the money I'm planning to spend on this AWS account. But there are other alarms you can set properly. For example, RAM usage, you can set manually an alarm that says, hey, whenever RAM memory has been at the 90% of capacity for the last 5 minutes, then also trigger an alarm. And that may increase the capacity units, with in this case are the capacity units are the instances running. And you can do that, yeah, whenever the capacity units, that has to do with the billing alarm. So the billing alarm has a metric that's which its name is estimated charge. It doesn't make it doesn't make sense, this example, but whenever the estimated charge are over 5 or lower than infinity, then you want to trigger you can add an instance or remove an instance. But yeah, that is basically step scaling, and you can add another and another step, as many as you want. And the simple scaling, which is much easier, actually, it is just one step. Actually, it's like a step, but just one step, and it also reacts to CloudWatch alarms. But the name sounds like, oh, this is easier, but actually you have to set up yourself the CloudWatch alarm and the metric you want to measure. The metric may be already there, like CPU usage, but then maybe it will make more sense to use the target tracking scaling. There is a taste for everyone, options for everyone. Now let's head back to the instances. Let's see if the two are running. Yes, the two are running. One very important aspect of target groups is that the instance have to be registered to the target group. And you can monitor that in the target group menu. Actually, you can refresh here and you can see that you have now two instances associated to this target group, and they both are healthy. Here you can actually specify that, or you can verify that I choose actuator health at the root, the URL for health check. And you can configure, for example, the healthy threshold, 5 consecutive health check successes, interval every 30 seconds make a health check, and the success should be at 200, and many details, yes, related to the health checks. But yeah, here we see both instances are healthy. That means the autoscaling group created a new instance and it was successful. I mean, now we may see here in the application load balance, I mean, in our what the end users are gonna see is that their requests are gonna be forwarded to two instances. And now pay attention, if I refresh here, now we see that the number may change. Oh yeah, it changed, but it doesn't change anymore. That is weird, because I tried this example in other occasion and it was alternating like a real load balancer. Maybe I can erase the cache. I don't know if that has to do with this. Or yeah, that's weird actually. We do have two instances. Oh, look at this, guys. An instance has been shut down. Why? That is a very good question. I didn't expect that in this video, but hey, sometimes unexpected stuff happens and we learned about it. So let's see what happens. The first thing I'm gonna do just to troubleshoot this problem, I'm gonna see the system logs of these EC2 instances. You can go to monitor and troubleshoot and get system log. And now let's see what is going on, what happens. So what happened? First, you can see that the image was correctly pulled from the ECR, Elastic Container Registry. Then the container should have been started. So the image was downloaded, as it seems, yes. But doesn't look like the container was run, actually. I don't know. Yep, it doesn't seem like that, because normally it would say, okay, a container was being run. And it was weird because both instances were healthy, as you saw it. But yeah, and then we just had to debug this. Unmounted Docker, enter disable state. Yep, I don't see actually anything that could say me so much here. Maybe we can recap this, but let's go to the autoscaling group and see what happened, because the autoscaling group activity can also show us some insight of what is going on in our autoscaling thing. Oh, okay, so it has to do with target tracking. Oh, the target tracking kicked in, so it worked as it should. I mean, that is okay. The guy said, hey, you are not using the 70%, you are not using the 70% of your CPU, and you have one spare instance that is doing like nothing. So I'm gonna shut it down, because that is what the policy is doing. Actually, everything worked as it should. That wasn't expected, because whenever I did it, the same example yesterday, and I think I was too quick to let the target tracking policy do its own task, but it worked as it should, and I'm very glad about it. That means we don't have to fix anything. The example just worked as it should. The target tracking CPU, yeah, the target tracking policy of that we set up did its work and just shut down one instance. But yeah, I'm very glad it worked as it should. Although the desired capacity is 2, now the desired capacity actually went to 1 automatically from the policy. Okay, I didn't expect that too, but so that means that is a very important lesson for today, guys, for me and for you. And that is why I do these videos, guys, because I learned a lot on the way, I mean, explaining to you. So our manual setup of this increasing capacity, decreasing capacity, whatever, was overridden with by this dynamic scaling policy. This has more precedence. That makes sense, actually. So if I would like to completely gain control over this autoscaling group, I would have to delete this policy. And actually we can do this. I'm gonna select that and let's disable it so we can have it. Where do I see the disabled? That is a very good question. Okay, so there is like a status, it says it is disabled, and now I can safely manually again trigger one extra instance, and I know for sure that this time it is not gonna be shut down by the autoscaling policy. And we should see yes, now it's gonna launch a new EC2, and everything should work as I expected initially. But yeah, so guys, what is left now to see? So we already saw the target group, the load balancer, how can we connect both of them, and then how can we set up the autoscaling group. I think I have not shown you guys how to create a new autoscaling group. So you have this button here, you can name the autoscaling group. You have to create the launch template I explained you before, but whenever you have created it, you can select it here, and then you can just select the version of it. I selected a random launch template, but actually this is the one I'm using right now. And then you can configure the VPC, the available subnets, where the running instance are gonna work. Actually, you should select the same subnets of your load balancer. That makes sense. But I think actually you can leave that empty and let the autoscaling group set itself the subnets. And then you can click next. Oh no, you have to select them. So I will choose the same ones that I chose back then for the load balancer. And then that is here this is the crucial step where you have to choose which load balancer to attach to this autoscaling group. And you do this by actually attaching to an existing load balancer, because you may create the load balancer afterwards, but it is easier doing it, so I think this way. So you just choose the target group, and the load balancer is going to be automatically connected, so to say, to this autoscaling group. And the health checks, there are two health checks for an autoscaling group. There is this default health check that is you cannot disable it. It checks the status of your instances at the hardware and at the software level. There are two kind of instance statuses. You can learn more about it in the AWS documentation, but yeah, you have those two checkups, so hardware checkup and software checkup. And then you can also check, and I recommend to also check this checkbox, that is the ELB health check. And the health check grace period, that means the elastic load balancer is going to check if your instance is doing well just after 5 minutes, or you can actually modify this amount, but that depends on whether your boot time is low or quick. If your instances boot very quick, then you may lower this, but yeah, that depends of your instance, of your application, how fast is being somebody, for example, how long it takes to download the image from the registry and to launch the container. That is the measure of your boot time, for example, or also of the setting up of your instance, of installing the operating system, everything. You have to take everything into account. And basically that is actually, I'm not gonna go into any more details, but now we should have our two running instances. Yes, there are two running instances. One was terminated, as we already saw. And if we head to target groups again, we should see two healthy instances. And now if I go to the load balancer and I refresh, I should finally see two IPs. Also, that means our requests are being distributed to two machines, because we are seeing that we are getting the IPs of two machines. What does this? I'm going to show you that in the Spring Boot application, and that is going to finish this video finally. But that is just this route server ID, where I get the environment variable server ID. That is just an environment variable I load with Spring Boot this way, very easy. And remember that in our user data, or this is the boot script that is run at boot start of the instance. We are creating this environment variable server ID with the host name of the machine. So every application is aware of the server it's running, but just because of this name, nothing else. It's not like we are leaking a very important information about the server other than its IP. But anyways, I wouldn't do that in a real production application, because leaking the IP would be too much of information. But this is just an example to show you that the load balancer is actually loading, balancing the load, I mean. So guys, that was the video of today. I'm very happy to have the opportunity to explain to you all of this stuff. If you have any more questions, please just write down them in the comment box below. Don't forget to like the video, to share this video with others, and subscribe. And yes, we see you, nos vemos en la próxima semana, así que hasta luego.